Alright guys, welcome to lesson 5 of unit 6. Today we're going to learn about something called the factor theorem, and we're going to use that to factor polynomials. Now we've already learned how to factor, right? But those basic factoring strategies that I shared with you back in lesson 6.2, they're only going to get us so far. There's some polynomials that have more than 4 terms, or maybe even if they do have just 4 terms, the box method just doesn't seem to work. So what we're going to be learning here is another strategy for factoring. Before we begin though our regular lesson, let's kind of review something. A little while back I gave you guys a test, and I asked you guys to do something like this. Now you don't need to write this. I want you guys to just go ahead and watch this here. And now some of you guys might remember we had a problem maybe like this, right? And that kind of stumped you, because you know that we need to break this thing apart, right? And that's what we call factoring. But the problem is that that's a really big number. We're not used to it, and a lot of you guys just didn't know, well, what the heck can I factor that into? It's too big. It's too much. And so wouldn't it have been nice if I told you, well, one of the things that goes in there is 7? If I told you what one of them is, how could you find out what the other one is? Well, if you just take the number that they give you, and you divide it by the number I tell you. So let's say I told you that one of the factors is 7. You could divide it. That's going to be a 4. And then 7 goes into 63 9 times. So it's 49. So basically, if I tell you what one of the numbers is, you can find the other one by dividing, right? And that makes it easier. And you get to a number that's smaller so that you can factor it more, okay, just using your basic knowledge of factoring. Well, today we're going to be dealing with polynomials that are a little bit like that. We're going to start by giving you guys a polynomial that's really big and irritating. I'm just going to make one up here really quick. Once again, you don't need to write this. I just want you to watch. Okay, so let's say we had this. Well, we don't even have a strategy for that. There's way too many numbers in there. You know, our factoring strategies for polynomials were only good for up to 4, but this one has too many. So what can we do? Well, here's what I'm going to do today. Is I'm going to say, well, one of the factors that goes into this thing is x minus 2. Okay? So but how many times does it go in there? What's going to be the other factor that multiplies with it to make that? Well, our answer is going to come by doing some division. We're going to do synthetic division. Take that number and put it there. And you're going to figure out your answer, and whatever you're going to get, that's there. And therefore, you will have split it up. Okay? And so that's kind of what we're going to be doing today. We're going to start off with some polynomials where our regular factoring methods don't work. And so what you're going to have to do is we're going to have to find a factor first, and using another method, which you'll learn in the lesson. And once you know that factor, you can just do synthetic division to break it down into something smaller. And hopefully after you've broken it down into something smaller, you can use your regular factoring methods to finish it up. So that's kind of the idea there. All right? So without any further ado, so let's go ahead and jump into the lesson here and see what's going on. So let's review a basic factoring technique here. Right here we've got a trinomial. And let's say I want to find the roots first of all. So I'm going to plug 0 in for y. This is just a review from last class. And then we're going to factor it using the box method. And if you did the box method, this is what you would get. And then you're going to set each piece equal to 0 and solve, and there's the roots, right? That's old stuff. We've done that in the past lesson or two. Now, here's what I want you guys to pay attention to. If my root is 2, then my factor will be x minus 2. So the factor, whatever your root is, like let's say your root is a, then the factor that created that root would be x minus a. So that's kind of the idea there. Likewise, if my root is negative 1, then the root will be x plus 1. Okay, so the factor will always have, I think I might have said that wrong. Let me say that again. If your root is negative 1, then your factor is x plus 1. So the factor will always be x and then the opposite of the root. All right? And that's what we call the factor theorem. It's pretty straightforward. So here it is. If c is a root of a polynomial, then x minus c, or the opposite of c, is a factor of that polynomial. All right? And we're going to use the factor theorem to break down some polynomials in another way. Now, for this particular polynomial right here, it has 4 terms. So you might think, okay, well, why don't we just use the box method to factor it? Well, what you're going to find out is that the box method actually won't work. Okay? The box method doesn't always work. And so we're going to factor this in another way. So the first thing we're going to do is, I've broken this process up, but I just want you guys to know what the big idea is here. The big idea is I want to factor this polynomial using the rational root theorem and the synthetic division. Okay, so instead of the box method, we're going to use the rational root theorem and synthetic division. All right, so I've broken the process up into 5 steps. All right, so here we go. The first step is to use the rational root theorem to find all the possible rational roots. So rational root theorem is where you find all the numbers that go into the last number, which is 1, 2, 3, and 6. Then you find all the numbers that go into the first number, which is just 1. And then you make as many fractions out of that as you can, and I'm only going to be able to make those ones. So I end up with plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. So there are altogether 10 rational roots that are possibly roots for this function. Now, technically what you would have to do at this point is something that we did last time. Last time what we did was we found out, okay, so these are only possible roots. How do I know which ones are the actual roots? Well, what you would do is you would plug each one in, and you would keep doing that until you got one of them that makes the equation equal 0, right? Well, I'm going to save you the trouble. I'm just going to tell you which one makes the equation 0, and I'm going to tell you that x equals 3, this one here, is the one that will make the equation equal 0. So that means that 3 is a root. Now, we're going to use the factor theorem for this. If 3 is the root, then what factor would that be? Well, according to the factor theorem, it's going to be x and then the opposite of this number. Okay? So that means that this is a factor of this expression, which means that it should divide in there evenly. So now we're going to do synthetic division. That's something we haven't done for a couple of days, so you'll get a nice little review here of how to do synthetic division. So let's go ahead and do a little bit of synthetic division. I'm going to need some writing space for this, though. Okay, with synthetic division, we draw our little chart. We take our coefficients from our original polynomial, put them there. And I want to divide this polynomial by this factor. So I'm going to take this root here, -3, but we would put the opposite there, so it's a +3. And then we bring it down. We multiply and put the answer here. Add down, multiply, add down, multiply. And at this point, if you don't end up with a remainder of 0, something's wrong. Okay? Because if this is a factor, that means it should divide in here evenly and there should be no remainder. Okay? So, here's my answer to part D. We have no remainder, constant x and x squared. So here it is. We have x squared plus x minus 2, and then my factor, x minus 3. So that's how you can factor using synthetic division and the rational root theorem. So before I go any further, I just want to review the process with you one more time, okay? Because we just covered a lot of ground. So the first thing I did was I found out what some possible roots are. So one of these 10 numbers, or sorry, 8 numbers, is a possible root. And you know which one is the root based on which one, if you plug it in, you get 0. And I told you, just because I'm a nice guy, that one of the factors that gives you 0 is 3. So 3 is one of our rational roots. After you know which one is a root, you also know, therefore, that a factor of that polynomial will be x minus 3. And since you know that that's a factor, you know that if you divide this polynomial by that factor, you're basically going to end up factoring the polynomial. And by doing that, we ended up with x squared. Well, actually, let me rewrite that. We ended up with our factor times x squared minus 2x minus 1. Was it minus 1 or was it plus 1? Can't remember. Hold on. Okay, I found my mistake. It was x squared plus x minus 2. There we go. All right, and so that's a new way that we have to factor a polynomial. Find the possible roots, find the actual root, turn that actual root into a factor, and then use synthetic division to factor it up. Okay? All right. Well, now, after you get that far, once you get to a place where you have something a little bit simpler, now we can just do our basic factoring strategies on this thing. So use basic factoring strategies to completely factor the polynomial and find the rest of the roots. So this one's as factored as it's going to get, but we need to factor this one now. All right, so that one has 3 terms. Now, how do you factor a polynomial with 3 terms using our basic factoring strategies we learned in 6.2? It's a box method problem. So we ask ourselves what times what makes x squared, and that would have to be x and x. And then we ask ourselves what times what makes negative 2, and one of them is going to be negative, one of them is going to be positive. Then we complete our box. And then we make sure that these numbers on the diagonal actually do combine together to make the middle. And I need a positive x, not a negative x, which is what these two give me. So when that happens, we talked about how you switch the signs. So we're going to make this 2 a positive, and we're going to make the 1 a negative instead. And that will switch the signs around the way that I need it to. All right, cool. So now I've got x minus 3 and the trinomial just factored into x plus 2 and x minus 1. Now if you want to find the rest of the roots, you just set this thing equal to 0 and you solve it. So x minus 3 equals 0. We know that's going to give us x equals 3. We already knew that one. That was the one that I gave you. X plus 2 equals 0. We get x equals negative 2. And then with our last one here, we have x minus 1 equals 0. And we end up with x equals 1. So there's your other roots. All right. So there's a lot going on there, but let's kind of review once again what we did. Step 1, find your possible rational roots. Step 2, Mr. Bailey's going to tell you what one of your rational roots are. Then you're going to turn that rational root into a factor using the factor theorem. You just write x and then do the opposite of that number. And then you do synthetic division. You divide this polynomial by this factor. And then when you're all done, you put this factor next to the result, and you've reduced the polynomial or factored it into something smaller. And then from there, I made it so that you could just use one of the basic factoring strategies to completely finish it after that. Set each one equal to 0 and solve, and you're good to go. Okay? All right, let's have you guys practice this a little bit. So basically all we're doing is the only new thing that we're doing here is step C, where you turn this number into a factor. But the rest of it is stuff we've done before. Okay, so let's go ahead and begin. So go ahead and make a list of what your possible rational roots are first. Then I'm going to tell you one of them is 1. Then turn that into a root, use synthetic division, and then completely factor it after that using basic factoring strategies and find all the roots. So pause the video here, go as far as you can with it, and when you unpause it, you will see the results. Okay, so here's the answers here. All the numbers that go into 4 I put up here on the top, and all the numbers that go into the front obviously are just 1, so that's on the bottom. And you make as many fractions as you can out of all those numbers. You basically just end up with positive and negative 1, positive and negative 2, positive and negative 4, and that's it. So a total of 6 possibilities, and technically what you would have to do at that point is you'd have to go through and plug them all in until you found one that makes 0. But like I said, I'm going to save you guys the effort there. I'm just going to tell you what one of them are. One of the roots that work is 1. Part C, if you turn that into a factor, then that would be x minus 1. So now, in part E, we're going to divide this polynomial by this factor, and I've shown my work up here, and here's the final result down here. After you do the synthetic division to factor it, you put your factor here and the result there next to it. And you guys could check the work if you want to, just for fun. You could multiply this times this, and you should end up with what you originally had. It's just another way to split a polynomial up. It's just that instead of using a traditional factoring method, we use a division method to split it up. Anyway, after that, you can use a traditional factoring method of the box method on this to get x minus 2 times x minus 2. And then setting all 3 of these equal to 0 and solving, you basically just end up with x equals 1. And x equals 2 for the other roots. So basically we just have x equals 1 as a root and x equals 2 as a root, and that's it. Alright, and so that's how you can use the rational root theorem in conjunction with the factor theorem and synthetic division to factor a polynomial all the way down and find its roots. And once again, why do we like to find the roots? Because, well, it helps us with graphing and stuff, which we'll get to a little bit later. Up until now, though, we've only been finding rational roots. Those are roots that, you know, are basic fractions or whole numbers. But we haven't been dealing with any kind of roots because you could have some really strange roots, roots that have square roots in them and things like that that are not rational numbers. And how do we find those? Well, there's a variety of ways. We're only going to look at one case of how to do it. But let's go ahead and do an example here so we get to practice our strategy here a little bit more. All right, so use the factor theorem to find all real roots. Now notice I'm saying real roots instead of rational roots. And what that means is we're going to go beyond just finding the fraction and whole number answers, and we're going to find the weird funky ones that have square roots in them also. Okay, so all the steps are pretty much the same. It just gets different towards the end. So first of all, we find all the things that go into 2. That would be 1 and 2. Then all the things that go into 1. And we make as many fractions out of that as we can. You really only end up with 4 possibilities. Plus and minus 2, plus and minus 1. And then technically we would plug in all 4 of those until we found some of our roots. But I'm just going to tell you that one of them is 2. And so what factor would correspond to that? That would be x minus 2. Then we're going to use synthetic division to reduce the polynomial, or to factor it. So I'll show my work up here at the top. So we're going to divide this polynomial here, 1, negative 4, positive 3, and 2. We're going to divide that by x minus 2, which means I'm going to put a positive 2 out there. When you do synthetic division, you always take the number of the divisor and you do the opposite there. All right, so bring down your 1, multiply, combine down, multiply, combine down, multiply. Should end up with 0. If you don't, something is wrong. So the answer to part D then will be our factor times the result. So that's the end of part D. For part E, we want to find all the roots. Okay, so that means we want to factor this and set it equal to 0. Now, here's the problem though. If you guys tried to factor that, it's not going to end up being factorable. I'll demonstrate it for you. But if it were factorable, then we would have more rational roots. Because anytime you factor, you're getting rational numbers. But you guys are going to find out here that on this particular problem, it just doesn't factor. That doesn't mean that it doesn't have roots. It just means they're not rational roots. So let me show you. I'm going to try to do the box method on this, and it's not going to work. X squared is going to go on the top left. Negative 1 is going to go on the bottom right. Now there's only one way I could possibly get negative 1 by multiplication when you're dealing with just regular whole numbers. And that would be 1 and negative 1. But when I put these two together, that's not going to give me the middle. And there's really no way to change this. I mean, I could switch where I put the negative 1 and the positive 1, but you're actually going to get the same answer. And I can't pick different numbers. So this polynomial is actually just not factorable. It doesn't work. There's no way to get two things here that will add up to make negative 2. So the reason for that is because it's not factorable. It's prime. Okay? But that doesn't mean when we're done, so check this out. Right now for part E, we have x minus 1 times x squared minus 2x minus 1. And I want to find the roots, so that means I'm going to set it equal to 0. All right, so we do x minus 1 equals 0, and that's pretty nice and easy. It's just 1, which we already knew because that's the root I told you anyway. But then this guy didn't factor, but we could still set it equal to 0, right? How do we solve that? Well, I'll give you a hint. This is a quadratic equation. So how do you solve a quadratic equation in standard form when it equals 0? Yep. This guy, he just keeps coming back. It's a very useful little formula. So B goes in the first two spots, A goes in the next two spots, and then C goes in the last one. All right, then we break down our square root. And in this case, we can reduce the 4, 2, and 2. And we end up with that. So this is an irrational root because it has a square root in it. So I've got 3 real roots for this problem. I've got x equals 1, so it touches the x-axis at x equals 1. But it also touches the x-axis at 2 plus the square root of 2 and 2 minus the square root of 2. All right? So what you guys are going to notice here in this problem, I'll back up a little bit here, go back to the beginning, is most of the steps are the same. Find your possible rational roots. I'm going to tell you one of them so you could turn it into a factor and do synthetic division to break it up. But when you guys get to your last step, you're going to realize you're going to have a quadratic equation there. And that quadratic is not going to factor. Okay? And so you're going to have to use the quadratic formula to find the roots for that particular expression. Okay? So that's an example of one way you could find a non-rational root, and that's just using the quadratic formula. All right, so I'm going to let you guys try one of those. There you go. Go ahead and pause the video here, give it a try, and see what you get. Okay, so here's our answer. So for part A, plus and minus 1, plus and minus 2, plus and minus 4. For part B, I tell you that one of the roots is -1. So for part C, that means the factor will be x plus 1. For part D, we're going to do our synthetic division. Your setup is going to have 1, -1, 2, and 4 inside the bracket, and the opposite of this number here, which is -1, outside the bracket, and then follow your process. You should end up with 0 here, of course. And so for part D, the reduced form will be x plus 1, our factor, times the answer of our synthetic division. Now, for part E, this is not, the quadratic here is not factorable, so we have to use the quadratic formula to find out what that would equal if we set it equal to 0. So for the factor I gave you, we end up with a root of -1. That's your only real root. But when you do your quadratic formula, you actually end up with an imaginary answer. And so these are imaginary roots. So they're actually not even real roots. These are imaginary roots. And that can happen too. Okay? But that is the end of it. Let's go ahead and call it quits there, and then we'll see you guys next time.